Hi everyone, welcome back. Lastly, we talked about this KAZE Keypoint-Detector class. Also, we made a simple example with an image about detecting the key points with the default parameters. Also, we compared this KAZE and the GFTT detector, which we already learned in the previous video, and we already compared them. Also, in this video, my plan is focusing to the member functions to the parameter of this KAZE class. Okay. We can switch to the class. This was the code from the previous video. If we run this, we are gonna see the detected key points. In here we are drawing these yellow circles, which is the detected by the KAZE backend, and also we are computing the descriptions. Also, we discussed this in the previous video. This is not only giving us the key points, it also gives us the descriptor belonging to the each key point. This was the main difference between the KAZE and the GFTT detector class. Okay, and in this video we are gonna focus to the member functions to the parameters. Maybe we can split the screen so we can see both. And here there are some member functions we are gonna focus on. Before that, since we need to set and we need to see the difference at the end, I want to check the key point and the descriptor size at the end so we can compare what we changed. Okay, visually also we are going to compare, but also I want to see the results. For example, I want to see the key points dot size. If it changed, the parameter changed the size with the default one, I want to see the difference. And also similarly, I want to see the descriptor size. Okay. So let's start. Also, the important one, you need to set all the parameters before detect and the compute function. Otherwise, it's not gonna consider the parameter you are assigning in the behind. Of course, you need to set before this detect and the compute function. Okay. KAZE just we are gonna start with the extend. Before that, maybe we can see the standard. Just see the default of the get extended. Just KAZE get extended. Okay, so I want to see the default value of this get extended, which is 0. So we are gonna make it now true, which is not the default one. Set extended and true. Okay, by doing this, it's just gonna change the description result. For example, this was the descriptor output and this is the key point output. Let's see, now it's not gonna give us the each descriptor in 64 byte, but it's gonna give us 128 bytes. So this is just extending that. What it means actually is meaning is increasing the details giving us as output. So this parameter increasing the description details. So if you are making this true, it's gonna give you more detailed descriptions. So this is doing that one. Also, since we are not making a comparison in this video about the descriptions, we are just see in the output in the image, we are see the key points with the yellow circles. But maybe in the next videos we are gonna focus these descriptions. Maybe in that part we can also see the what this set extended actually changing. We can see in that also. Okay, the next one is the get upright. This is also related to a descriptor, which is this is gonna make rotation invariant or not. So if you are setting this as true, I think default is false. Okay, so if you are making this true, so it's gonna give you in the description part also rotation invariant. So even you are changing the description, I mean the rotation, if the rotation changes in the following, in the belonging corners key point, is still considered, is still gonna try to remember that key point. So this is about the rotation invariant. So in your case, if you do not need even rotated or not rotated, if you are not worried about it, you can keep as it is, because defaultly false, you don't need to make it true. So it's gonna increase your efficiency. Okay, the next is the threshold, which is related to the key points. Also we discussed in the GFTT detector part. Let's see what is the default threshold value. This is 0, 0, 1. So we can a little increase this because we see many noisy circles. Let's set threshold. It was default like that. Let's make it 0.02, for example, little higher than that. Now we see at least many noisy circles exist here before, so now we do not have them. So at least the key points now more valid than before. So you can play with this threshold so to be able to increase the accuracy. So this was doing that. And the next is, maybe before this we can focus this diffusivity. This is gonna, in the GFTT part also we talked about, this is basically just doing and just changing the background kind of medium blur doing. So according to the diffusivity type you are giving, the defaultly, let's see which one, get diffusivity, oops, this one. And defaultly this it was like this, and we see this result. Let's change it with this, and also we were taking 429 key points, and let's change it to do, which was KAZE diffusivity type, and give me the one, this G1. Let's try. We were taking like this number 429. We are getting now less. You see some of the circles according to the calculations are removed. So this is basically just some other types which is mathematically, but also there are some logical explanations. Maybe if you are really interested you can check into the details, but basically they are just playing with the background, playing with the skeleton of the image. So they are doing that job. And the next is, oops, what we were talking, okay, and this number of the octaves currently, let's check what was the get number, oops, get number of octaves and the octave layers, and let's see what was the default one. Default is 4, as we see in here. This is if you are dealing with the high resolution images. For example, currently I'm dealing about 2 megapixel maybe, yeah. But if you are dealing with 10 megapixel or 20, I don't know the case. But if you are dealing with really huge resolutions, in that case, for example, with this default KAZE, which is 4, maybe you are not gonna get accurate key point detections. But if you are increasing that into the let's say from 4 to the 12, which is gonna increase the computation time really higher. For example, even I try, I don't know, it's maybe gonna take a couple of minutes. Okay, let's make it 12 and let's try how it looks like. Yeah, even my machine now started to get noisy. My yeah, it's working noisily. Maybe you hear also. So this is increasing the computation time, but you are gonna need this in the case of if you are working with the really high resolution images. Okay, I'm gonna close this. So this is doing that job, but for small resolutions the 4 is the suggested value, so it's okay. But if, yeah, as I said, like this. Also number of the octave layers, also about the accuracy, if defaultly, what was this one, oops, in here, let's try, and this was defaultly also 4. If you also increase this, it's gonna increase the computation time, but at the same time it's gonna somehow increase the accuracy. Yeah, for this video simply I just wanted to talk about the parameters of this KAZE class, and I'm done for this video. Maybe in the next video we are gonna focus to the descriptions a little bit. We are gonna make an example. I'm done for this video. Thanks for watching. See you in the next videos.